So now we're going to continue our discussion of probability and counting, and in particular we're going to talk about the multiplication rule. So what you should do in this section is you should think about, you should break down a process into individual steps. And it's important that in order to use the multiplication rule, each step doesn't influence the other steps. So let's look at an example here. Let's say a certain pen is required to be a sequence of any 4 symbols chosen from the 26 uppercase letters and the 10 digits. So I want to know how many different pens are possible if repetition of symbols is allowed. So we're allowing repeat symbols. Okay, so we're going to think about this as there are 4 different, remember, break it down into its processes. There are 4 different symbols that need chosen. And so you're going to break it down into its individual steps. How many choices do I have for the first symbol? Well, I have 36 choices. It could be the 26 letters, and there are 10 digits that it could be. And then how many options do I have for the second? It's 36, the third 36, and the fourth 36. And then the multiplication rule says we just multiply these together. 36 to the fourth, or 1,679,616 pens are possible if we allow symbols to repeat. How many can we have? How many different pens are possible if repetition of symbols is not allowed? Well, again, break it down into your 4 steps. All right, for the first symbol, I have 36 choices. And then for my second symbol, I don't have 36 choices anymore because repetition's not allowed. I can't use the one that was chosen in the first one, so there's only 35. The next one, I can't use what was used in the first spot or the second, so there's only 34 choices. And the final one, there's only 33 choices. So there's 1,413,720 pens. And part C, what is the probability that a pen does not have a repeated symbol assuming that all pens are equally likely. So you get a pen randomly assigned to you. And so because all pens are equally likely, we can use our probability formula where we have our fraction. It's the number of pens without repeats over the total number of possible pens. So it's 1,413,720 over the total number that were possible, 1,679,616. So if you convert this into a percentage, it would be 84.17%. So it's pretty likely that if you were assigned a random pen, it would not contain a repeated symbol.